All right, so we know through our hand baking process that we do here at the school that cured meats are cured with salt. But what actually in the salt creates a cure for that to be preserved in the meat? Cooper, do you know? No, you just know that it's salt, right? So we know that it's got to be some type of sodium, okay? So what's actually in the salt is going to be a nitrite, all right? And in front of you, you have some handouts from the American Meat Institute that actually give you some facts on sodium nitrite. And sodium is just any type of salt, right? Okay, so I want you to read what sodium nitrite is, and then I want somebody in one of the groups to explain to me what sodium nitrite is.
Sodium nitrite is a salt and antioxidant.
It's a salt and an antioxidant, exactly. It's a salt and an antioxidant that when it gets into those cells of the meat, creates a preservative that keeps bacteria from growing. Okay, so for thousands of years we've used preserved meats to store meats. Before we had access to cooler temperatures, before we had access to refrigerators or ways to store meat, ancient civilizations would bury the meat in sands along the beach. And we know that the ocean is really, really salty. And what that would do, over time, it would actually cure that product so that they could keep it for long amounts of time. So now we accomplish this by using very scientific processes with sodium nitrite and sodium nitrate, which are just two different types of salt, that over time will create that exact same preservative method in the meat. Now, we know that with our ham baking process that we use here at the school for the hams that we cure, we use a country cure, where a dry salt is applied, and over time, moisture will leave the hams and the bacons that we use, and the sodium nitrite will enter. Okay, but there are other curing methods, or a tavern or brine cure, that you inject with liquid. This does not take as long, but what we're going to try and study here through this lab is whether injecting with a liquid cure and then soaking it in a brine over time will give us higher nitrite levels in the meat. So how this happens is through a process of osmosis. Okay? So here we have a picture of the animal cell. As the water goes out, H2O will leave the cell, and NO2, which is nitrite, and NO3, which is nitrate, will enter the cell. Okay, and through this, so we all know what osmosis is, right? It's a liquid exchange between cells. Okay, that cell membrane will open and allow water to pass through, and as that salt comes in, it causes more water to leave. So it's sort of like a vacuum, okay? But if we inject, that might be different. Okay, so what we're going to look at is the levels of sodium nitrite in an injected piece of cured meat and a piece of cured meat that's done through a regular dry cure. Okay? Now, we know from the West Virginia Department of Agriculture that the weight of the meat and the amount of salt that you put on, or nitrate that you put on, needs to be 7% of the weight. Okay, so for this piece of meat, Braden, how would I figure out how much how much salt needs to go into my liquid? An equation, right? But how would I do that? We're going to have to weigh the meat first. Okay, so if you will go ahead and weigh your sample there. Okay, now to keep these constant, okay, what are we going to have to accomplish? They're going to have to be very close to the same weight. So theirs is right at 5.6 pounds. .52. So we are going to have to take a little bit of weight off of one. We'll grab a knife here so we can try and accomplish it a similar way. So how much meat did we take off?
0.8 pounds.
0.8 pounds. So we've got to accomplish similar weights so that we won't be too far off.
0.2.
102.
we go. All right, so now that we have an exact, we know that we need to multiply that by what? To figure out 7%. 0.07, exactly. So 5.52 times 0.07 will give us 7% of that weight, and that's how much of the cure that we need to apply. Okay, so 0.38, 0.39, we're going to have to round that number up, so we need 0.39. Now, if I'm using this as a canister for that cure mix, and I put it on here, what am I going to have to do first? Zero it out. Well, no. Let's go ahead and, yeah, that'll work. Instead of tarring, we'll go ahead and zero it out. So now we're at 0 pounds. We have the cure there. Add that until you get 0.39. Probably the whole scoop in there. Yeah, that's 0.02.
0.02. Takes another scoop.
You bring the bucket a little closer there.
Yeah, you can put more.
The whole thing.
Oh, just that.
Okay, now one more and this should be close. 4, so
Half a
just
scoop.
yeah. There we go.
Perfect.
Okay, so this first application method will be just like the hams and bacons that we put into cure before. All we will do is take the dry nitrite mix, okay, and add it, apply it all around it and on top of it, and through that osmotic transfer, we will see a change of water, and this will become full of water, and you can literally watch over time. If we were recording, we would see that salt begin to soak into the meat, and that's that exchange. So if you want to set that down, and you guys go ahead and apply that. Now, on the other, yeah, just like we do the others, try to get as much of it. That's good. And then underneath it as well. So now we've got to do the exact same thing again with this other side. Now again. Okay, the only difference with your all's group, we will have to mix this all into a liquid solution and get it saturated, and then inject it with this injecting needle. Okay, but we still have to have that exact 0.39 pounds of cure. Okay? Where do we get that number again? How do we know that's 7%? The West Virginia Department of Agriculture recommends that for appropriate nitrite levels within meat, within cured meats. Okay, so go ahead and start measuring out your 0.39. Okay, you want to keep as much of that off your gloves as you possibly can. Okay? No, you're fine. Okay, so this group is ready.
Cup or something?
When you get it saturated to a liquid state, and you can still see through it, and all of the salt has been taken. So what do you think is going to be better? Which do you think will give us higher nitrite levels? The brine? Think it will be more effective?
It'll be itself, you don't have to soak in.
need to inject it until the entire piece is saturated to the point that as you're adding water, it starts coming out the other entry points that you've used. Okay? Do you have any questions about what we're trying to see, what we're trying to look at? We all pretty much understand that we're just trying to look at the differences.
How long we gotta let them sit till we calculate the nitrite levels?
Okay, so he's
Not just
asking.
stick this in.
Yep. He's asking how long we have to let these things cure. So we know from, again, we're going to pull this directly from the West Virginia Department of Agriculture, that meat as it cures needs 2.5 days per pound. So we were at about 5.6. So we're going to have to do 5.6 times 2.5 to figure the exact number of days. Just that would be just a little bit under that, I think. Right around 2 weeks.
14 days exactly.
Okay. So as she's doing this, you could even come down around here so you can see this. I know this is a different process than what we're used to using. As she's doing this, we can actually see those muscles begin to expand as that water comes in, because even though it is a loin, there's still going to be sub areas within that muscle that are different, and they'll expand as that water comes into it. So quick review, what is sodium nitrite?
Antioxidant.
It's an antioxidant and a salt, and it acts as a preservative in this meat. So as we put that in, okay, you can see what I'm talking about. As that gets really, really saturated, it'll start exiting the other points, but we still need to get this a little better, especially down here. Okay, when you get to it, you'll feel it. The meat will get really hard as you.
Click when you go forward. Just keep it on the side.
What do you think could change the amount of nitrite that enters? Do you think it'll go better through lean muscle, or do you think it would go better through like fat? Lean muscle. Okay, so those back edges of that loin, where the back fat is, that could be an error in curing, right?
Mm-hmm.
What could be some errors within this lab that we're doing right now?
Diluted it too much.
Diluting it too much with the water, that could be a possibility. We don't see any salt on the bottom still sitting there, so I think we're okay. But we probably should have came up with an exact amount of water maybe. What else could be error? Human error, right? Human error in applying that and injecting this. That could all be human error. Miscalculation could be real easy, because those scales that we have are very, very touchy. So miscalculating, even being off just a little bit, could throw this. Yes. Yeah, it's a lot more solid than it was before, right? And that's because that muscle has become really, really saturated. Okay, go over and feel the top of the muscle there, and then feel this one, and feel the difference in the texture of the meat as it changed.
This needs salt. That's what I give to it.
Did you see that expanding as she was putting it in? Okay, and that's because this little tip of muscle from down here isn't connected to this upper loin part. Okay, and so now we know that it's super saturated to the point that it won't take any more water there. See that muscle expanding?
Mm-hmm.
So what we'll do with the rest of this, we'll submerge it in what's left. then in 2 weeks, we will pull these out. We will take samples and we'll do salinity tests. We'll also test the nitrite levels within the meat. Now we can't do that here, so we'll send it just like we do with our samples of hams. We'll send that to the State Department of Agriculture, which is down in Charleston, and they will do that nitrite test for us. And when we get those results back, we can analyze that data and actually see which curing method is going to give us better nitrite levels. Whether it's that dry cure, whether it's this liquid brine. Okay, so what I want you to do now, I want you to take these and put them in the cooler. That's going to keep them at around 40 degrees, which is right at that area where we see increased bacteria growth. All right, if everybody could wash their hands, and then we'll start back up in the classroom.